Using Kelley's equation in item discrimination analysis to evaluate multiple choice exam questions in Excel to identify questions that are good in discriminating high performing students from low performing students, and to classify the questions as either a good question or a bad question, following the equation of item discrimination equal to upper group minus lower group divided by 27% of the total students. And we're going to perform the analysis in Excel. Here I have a data from an Excel sheet from exam results for 20 students answering 20 multiple choice questions from question number 1 to question number 20, and the score for each question is recorded as either 0 or 1. 0 is the wrong answer, 1 is the correct answer. So here we have a categorical data, dichotomous data, to possible category 0 or 1. And we want to determine the item discrimination for the 20 questions to determine which question of these are good and which are bad based on the analysis. And the first step to do the item discrimination following the equation proposed by Kelley is to calculate the total score or the overall mark achieved by each individual student. So we are going to generate here a column and we call it overall mark. And to calculate the overall mark for each individual participant, we need to add the score from all the questions from Q1 to Q20 all together. And the way to do that, click on the cell here, insert equal sign, then type sum, select the sum formula, and in the sum formula drag the range of the data to calculate the sum from Q1 to Q20. A value is calculated, 17. The grade or the mark, the overall mark for the first student is 17. And to calculate the rest, we just need to drag and hold and drag the value to the last student. So to auto calculate and auto fill the value for the over mark for each individual student. So we've calculated the overall mark. The next step in item discrimination is to arrange or rank those overall mark from high to low, from descending in a descending order. And the way to do that is to click on the data itself, select the whole data, and then click on sort filter and use custom sort. In the custom sort, make sure that this my data has headers is ticked, and we're going to use the column which is labeled overall mark, as this is our reference for doing the item discrimination analysis and a reference for ranking the data from high to low. And we're going to rank the data in the order of the largest to the smallest. If we click on OK, again we can see here that the software has arranged the data from the highest to the lowest. So the lowest score by students was 8 out of 20, and the highest is 17 out of 20. Now, following the arrangement of the overall scores in descending order, we need to generate the upper group and the lower group. So we're going to type here upper group, lower group, then ID for ID discrimination, and then ID percentage. And to calculate the upper group proportion and the lower group proportion, we're going to use the ranked value on the overall mark. And for the upper group proportion, we need to select the top 27% of the total student who achieve total marks. And for the lower group, select the lowest 27% of the total score. So student who scored lowest. So we have to generate two groups, and the number of the student to select will be equal to, if we have 20 questions or 20 students, and we want to arrange them into upper and lower group, and we want from the upper group to include 27%, then we multiply that by 27 to get a value of 5.6, which will be approximated to 6. So each group, upper and lower, each one of them will have 6 students in it. The scores for the 6 students for the upper and the lower group. And to calculate the upper group values, and I'm going here just to highlight this, divide these groups, this data into upper and lower. So if I select the first top 6 students and label them, give them a label of green, as this is the upper one, and the lowest group 6, select from it as lowest 6 students. I'm going to keep it red. Now what we want to do here for the upper value, we need to insert the equal sign and then type sum and select the sum formula. In the sum formula, we are going to select the first 6 values here in for Q1, close the bracket, and then open another bracket and put the sum formula in a bracket, and then divide that by 6 since we have 6 students. So this is the way to calculate upper group proportion. If you click on enter, the value is generated. And we're going to do the same for the lower group. In the lower group, we're going to insert the equal sign and then type sum. And then we are going to select for question number 1 the 6 values, the lowest 6 values here, close the bracket, again doing the same thing, put the sum formula with the value in bracket, divide that by 6 as the lower group has 6 students in it, press enter, a value has been generated. Now to auto fill and auto calculate the value for the rest of the group of the questions from Q2 to Q20, we're going to select, select the first row, drag it to calculate and autofill the value for the upper group, and do the same thing for the lower group, select and auto and drag to the last question number 20, and a value is generated for the upper and lower group. So here we have now upper group and lower group, and the next step to determine the item discrimination is to subtract this upper group from the lower group from the upper group. And the way to do that is click on insert, click on the cell, insert equal, select the first value here from the upper, then select, then put the minus sign, and then select the lower group, and then click enter. A value is generated for ID there. So this is the item discrimination for question number 1. Again, drag and select and drag to autofill and auto calculate for the rest of the questions. So here we have the value for item discrimination for the 20 questions. I'm going to decrease the decimals to make it a little bit by clicking on cell format and then number decimal. We're going to make it, change it, or make it, keep it 3. or even I'm going to change it to 2 to make it much easier to compare. Item discrimination value range from -1 to +1. A very good question. Good question has a value 0.4 or greater. A good question has a value of 0.25 to 0.39. And the bad question had a value of, or a value less than 0.25. And also ID value can be 0, or even it can be from 0 to -1. So those are all the possible range of value from -1 to +1. In the first cell here for question number 1 for the ID value is 0.33. This is a good question, as it can discriminate between high-performing student and low-performing student. The second question has a ID value of 0. 0 means that the question is not discriminating between high-performing and low-performing, so this is considered to be a bad question. So 0 indicate the question is bad, and 0 indicate the question is bad, and question number 4 also, so question 2, 3, 4 are bad questions, and they ought to be removed or excluded from the exam, or rewritten in another way that it's the ID for it will be higher. For this question number 5, the ID is 0.5, which is really a very good value, and this question is very good as it is greater than 0.4, and this question is very good in discriminating between excellent student and poor performing student. In this also ID value for question number 6, the value is -0.17. This question is discriminating between high performing and low performing, but the low performing students are scoring the questions correctly, and the high performing students are scoring the question wrongly. So this question ought to be removed from the exam, as it is not discriminating, and omitting it from the exam is the best way to get rid of it. Others value here, we can see here there is a question which is number 16, has a value of 0.83. This is a very good question, in fact an excellent question in discriminating between high and low students. Question number 19 and 20 and question number 13 has an ID value of 0.17, which is below the range here. Anything less than 0.25 is considered to be a bad question. So this one and this one and this one is a bad question, ought to be removed from the exam, and this one -1 is also ought to be removed from the exam. These 0 value for the ID are bad questions, that they do not have the power to discriminate between high and low performing student. So this is the advantage of using item discrimination analysis based on the Kelley's formula, as it will permit identifying and evaluating questions and determining which questions are good, which are very good, which are bad, to remove from the test. Here, as we can see, out of the 20, 1, 2, 3, 4, 5, 6, 7, 7 questions out of the 20 questions for the multiple choice for this exam are a very bad questions that has to be removed from the future exams. So this is the way to do an item discrimination analysis in Excel. First you have to calculate the overall score, arrange the overall scores in ranks from high to low, and then group the student into upper and lower group and calculate the proportion in each group, and then determine the ID value for each question. We could also do a ID percentage by inserting in this here equal sign and then selecting this and selecting the ID value, multiplying it by 100 to generate the percentage of the ID, and we auto-fill and auto-calculate for the rest of the questions, and also we can reduce the decimal point here to something manageable and easy to recognize. So this is the benefit and the advantage of using ID for assessing multiple choice exam questions.